Welcome to myprojectbazaar.com. Now we are going to discuss about the product post-processing of compressed images via sequential denoising. Now we are going to discuss about the abstract for the process. In this paper we propose a novel post-processing technique for compression artificial reductions. Our approach is based on posing this task as an inverse problem with the regularization that leverages on existing state-of-art image denoising algorithms. We rely on the recent proposed plug-and-play prior framework suggesting the solutions of the general investigation problems via alternating direction method of multipliers, leading to the sequence of Gaussian denoising steps. A key feature in our scheme is a linearization of the compression decompression process so as to get a formulation that can be optimized. In addition, we supply a through analysis this linear approximation for several basic compression procedures. The proposed method is suitable for the compression techniques that rely on transformation coding. Hence, this process is well efficient to compress the image. Hence, the compression ratios are discovered. Hence, the reliability of the process is more, and the process is suitable for all the dataset images. Now we are going to discuss about the flow diagram for the process. This is the overall flow diagram for the process. At first, the image acquisition module is carried out. In this image acquisition, the input image is getting from the dataset. The dataset is the folder which consists of the several input images. After getting the input image from the dataset, the input image is converted into the block separations. When giving the block size as 6 or 18 means it will be segregated as per the size we have given. After the block separation, the DCT is applied. The DCT is abbreviated as an discrete cosine transform. After applying the transformation, the quantization is carried out. In this quantization steps, we have to quantize the image by the transformation. After the quantization method, we have to apply the dequantization. In this dequantization, the inverse quantization is applied. In this inverse quantization, the image is transferred once again. After the dequantization, the inverse DCT is applied in this process. At the second module, we have already applied the DCT. So here we using the inverse DCT to inverse the image, or otherwise we can reconstruct the image into an aspect quality. After the inverse DCT, the performance measures is carried out. In this performance measures, we have to calculate the three things: PSNR, MSE and the compression ratios. In this, the compression ratio is the main thing to discover whether the process is efficient or not. Now we are going to discuss about the initial running procedure. At first, open the MATLAB 2013 and change the current directory. If you want to execute the code means right click in the main_GUI.m file and select the option run. Now the initial GUI design was opened. In that you can see the several push buttons in the left to control the axis and the several axes in the right side to display the images. At first click the button input image. Now the dataset was opened. In this dataset you can select any one image from the dataset. After the selection of the input image from the dataset, the selected image is shown in the axis 1 with the title input image. Then click the button encoding process. Now we have to give the block size. Now I give the block size as 8 and click the button enter. After giving the enter, we have to once again give the block size. Then the third time also we giving the block size 8. Now the encoded image is shown in the axis 3 and then also the encoded result is shown in the axis 2. Now apply the DCT. Now the discrete cosine transform image is shown in the axis 4 with the title DCT image, and the corresponding values for the input encoded and the DCT images are shown in the table. Now click the button quantization. Now the quantized image is shown in the axis 4 and the flip matrix left to right direction is also shown in the figure 6. Now click the button next. Now the next GUI design was opened. In that you can see the buttons dequantization, inverse DCT, then decompressed image, denoising, then the performance estimation. At first click the button dequantization. Now the dequantized image is shown in the axis 1. Then we have to apply the inverse DCT. Now the inverse DCT is shown in the axis 2. The corresponding values are displayed in the UI table 2. Now click the button decompressed image. Now the decompressed image is shown in the axis 3 and the reconstructed image is shown in the axis 4. Now click the button denoising. After applying the denoising, the filtered image is shown in the axis 4 and after the filtering we have to analyze the performance. So after clicking the button performance measures, the performance estimation is shown in the bar chart. Here we have calculating the MSC, PSNR and the compression ratios. These values are plotted in the bar chart format. Thanks for watching this video.